Picture this. You're managing a massive project across 4, 5, or maybe dozens of different GitHub repositories. A bug pops up, and you need to find the exact commit message tied to a specific Jira ticket. Fast. What do? Waste 20 minutes clicking through tabs, searching repo by repo. There's a much better way. In this video, I'm going to show you how to build your own custom Model Context Protocol MCP server right on your local machine. With this setup, your local AI can scan across all your repositories simultaneously, connect the dots, and find that exact Jira commit message in seconds. The Model Context Protocol, MCP, is an open-source standard and framework designed to connect AI models like Claude, ChatGPT, or local LLMs to external data sources, tools, and applications. MCP provides a universal protocol. You build an MCP server for your data source once, and any AI application that supports MCP can instantly communicate with it. An MCP server can provide 3 main things to an AI model: resources, read-only data or context, like a local markdown file, log files, or raw database data. Tools, functions the AI can actually execute, like running a terminal command, searching a specific API, or modifying a file. Prompts, pre-designed templates or workflows that help guide how the AI should behave for specific tasks. Creating a Model Context Protocol, MCP, server in Python is incredibly straightforward thanks to the official SDK and FastMCP, a high-level framework that makes declaring tools as simple as writing standard Python functions with type hints. A step-by-step guide to building a local MCP server that connects to GitHub using open-source tools is given in the description. 1. Python before starting. Ensure you have Python 3.10 plus installed. 2. A GitHub Personal Access Token, PAT. You can generate one by going to GitHub, Settings, Developer Settings, Personal Access Tokens, Fine-Grained or Classic. It needs permissions to read repository contents and pull requests. 3. Python dependencies. Install the packages required to build and test Model Context Protocol, MCP, servers using Python. 4. MCP Server Code in Python. Create a file named server.py. You can copy the code from the description. This code utilizes FastMCP to automatically turn Python functions into LLM callable tools. 5. Claude Desktop. Install Claude Desktop for connecting the server to an LLM client. Run the following commands in your terminal to initialize the project. Run the following commands in your terminal to create a virtual environment. Run the following commands in your terminal, install the dependencies. All the install instructions are available in the video description. When installing dependencies, check for any warnings or errors and resolve them. Step 2. Write the MCP server code. Create a file named server.py and paste the following implementation. This code utilizes FastMCP to automatically turn Python functions into LLM callable tools. You can copy the code in the video description. MCP servers natively communicate using standard input-output (STIO), meaning you don't interact with them directly via browser, but rather let an AI client launch them. First, export your GitHub token in your local terminal session. Inspecting with the MCP CLI, the MCP Python package comes with a built-in development inspector tool. It creates a web UI that allows you to view and test your server locally before hooking it up to an actual LLM interface. Run the inspector in your terminal. Go to the folder where you have stored your server.py script and run this command. Verify that the MCP inspector has opened in your browser. Connect the MCP inspector. If you get any error, check whether you have exported the GitHub Personal Access Token as environment variable. Click on the Tools menu. Each function in the Python script is a tool. Click on the Search Comp Message tool. Enter the Jira number shop 2355 and click the Run button. If you see a success message, congratulations. Your custom MCP server is working. Now we will use the Claude Desktop to check multiple tools in the MCP server. Step 5. Connecting the server to an LLM client. We will use Claude Desktop. You can use any other LLM client. To allow an LLM like Claude to actually consume these local tools, you must tell the client application how to run your script. Open your Claude Desktop configuration file. Add your custom Python server config under the MCP servers block. Be sure to provide the absolute paths to your virtual environment's Python executable and your script. Restart Claude Desktop. In addition to setting the GitHub token environment variable, you must also add it to your Claude configuration file. Open Claude Desktop and enter the following prompt. List the commits with Jira Shop 2355. Within a few seconds, Claude will return the commit numbers and repository names. Let's verify the MCP server's response against the actual commit message on GitHub. As you can see, GitHub shows the commit for Jira number shop 2355 right here in the shopping repository. Let us see how the MCP server works to get the response. At mcp.tool, this decorator registers the function with the FastMCP framework. It exposes the function's name, docstring, and parameter types to the LLM, so the model knows exactly how and when to use it. The function constructs a GET request to GitHub's dedicated commit search endpoint. It packs all the arguments passed by the LLM into a perms dictionary, which request automatically appends to the URL as a query string. Authentication. It injects the GitHub token via the get_headers helper. If the request is successful, the function parses GitHub's complex JSON payload into a clean, human-readable, and LLM-readable plaintext summary. The function loop then strips away massive amounts of metadata and extracts only 5 critical pieces of information for each commit: repository name, short SHA, commit message, author name, and HTML URL. Every extracted line is appended to a list, joined by new lines, and returned. An LLM, invoking this tool, will receive a structured text block. If nothing matches the query, it skips the loop entirely and returns a friendly string. No commits found matching query. Let us do one more testing to check the repo product. Let us compare the response with GitHub. Yes, the number of commit messages match. The current MCP server is equipped with 5 core tools, each implemented as a distinct function within the Python script. The architecture is fully scalable, allowing you to add any number of custom tools to expand its capabilities. Current tool set. 1. Create pull request formats a post request to create a new PR using parameters like repository name, /base branches, title and body. 2. Search commit messages executes a GET request against GitHub's commit search endpoint using keywords supporting pagination and sorting. 3. List user repositories fetches and formats a list of all public or private repositories belonging to the authenticated user. 4. List repository files queries a specific repository path to return other items inside our files or directories. 5. List pull requests pulls a list of pull requests for a given repository, filterable by state, open, closed, or all. Let us test the pull request tool in the MCP server. Open Claude Desktop and give a prompt. List open pull requests in the repository product. Go to GitHub and open the repo product. Check the open pull request. It has one open pull request which matches with the Claude response. You can check the GitHub API in https://api.github.com and add additional tools in your MCP server. List files in the folder shopping_project in the repo shopping. You don't have to give the full path. Repo name and folder name will list the files. Since the username is given as default user in the Python script, you don't have to give your username. Why build a custom MCP server when official vendor options already exist? While vendor servers offer quick deployment, a custom-built solution provides distinct strategic advantages. 1. Control over scope and tool design. You decide exactly which operations are exposed. Your list repository files, search commit messages, etc. are a deliberately narrow slice of the GitHub API, easier for a model to use correctly than the full GitHub MCP server. 2. Tailored to your actual workflow. A custom server can bake in your conventions, like defaulting owner to your username, so every call doesn't need that parameter repeated. Vendor servers are generic by necessity. Yours can encode institutional knowledge. 3. Data residency/security boundary. You control where credentials live, what gets logged, and what network egress looks like. For sensitive repos or compliance requirements, that's often the deciding factor over convenience. 4. No dependency on a third party's release cycle. If a vendor server has a bug, missing feature, or rate limit quirk, you're stuck waiting. With your own server, you can patch it same day. 5. Combine multiple backends behind one tool. A custom server can stitch together GitHub plus Jira plus internal databases into a single coherent tool surface, which a single vendor's MCP server generally won't do. 6. Custom auth flows. Service accounts, fine-grained PATs, internal SSO. You're not limited to whatever auth method the vendor chose to support. Where vendor servers usually win instead. 1. Maintenance burden. They handle API changes, pagination edge cases, etc. 2. Broader, more complete API coverage. 3. Faster to adopt, no build/deploy step. 4. Often better tested against the underlying API's real-world quirks.
If you found this video helpful, smash that like button, subscribe for more automation tips, and hit the bell so you never miss an update. Thanks for watching, and I'll catch you in the next one. Bye. Bye.